Good morning, everyone. So today we are going to speak about histogramming MySQL and MariaDB. Me and my colleague Madhavan will speak about like how it's histograms differ in both MySQL and MariaDB. Yeah.
Yeah, very good morning to everyone. Thanks for joining the webinar. So I am currently interested in MySQL and cloud-based environment like AWS and Aurora and GCP, and I'm working on the on-prem services like physical and Linux-based machines. And currently working in clustering, MySQL clustering and its load balancers. And I'm active learner in MySQL-related topologies. And currently working in the Mydbops as a database consultant. I'm certified in Oracle MySQL 5.7. So I have worked on migrations and architecture changes in MySQL and its related topologies, and with a huge data set of 10 TBs. Yeah, over to you, Monu.
Okay. Thank you, Madhavan. Yeah, it's about me. So I'm a database consultant, working as a database consultant, MyDBs, experience in both on-premises and MySQL, on-premises MySQL and cloud-based technologies, and also a certified DBA. Yeah. So it's about our organization. So we provide the service on the top open source database like MySQL, MariaDB, Postgres, and MongoDB. Our organization is founded in 2016. We have 80 plus members team, and we have assisted over 1,000 plus customers. And also we are AWS partner, ISO and PSI certified organization. Yeah, so these are the two types of services which our organization provide. That's database consulting services and managed database services. Yeah, so it's a agenda for today. Like we will go through like what is histogram in MySQL, and histogram in MariaDB. Yeah, so first we will give the introduction, like what is histogram actually. So histogram is nothing, just an accurate representation of a distribution of numerical data. Like it's a graphical representation of numerical stats or data. So it can be more understandable. It's in graphical format. So in histogram will basically like it's a data for the tables column, but it will represent in a bar structure or in a pie chart. So it will more understandable to the humans. For RDBMS, as the same concept, like histogram is an approximation of data distribution within a column, within a specific column, like how the data is distributed throughout the column. It is an uneven or even distribution that represented by the histogram. So we will go through the simple data distribution that I have taken taken from the world database of country table of continent. So continent is a column. So every continent will have some region or some countries. So that I have distributed here, and then I have converted to the histogram. So with the histogram, we can morely like we can understand like yeah, this from this 0 to 40 or 0 to 20 countries are in this continent. So that will accurately or that will graphically show us like yeah, this is the data distribution throughout the columns. So that will be more understandable to humans. So same way in MySQL also, if we give the histogram stats to the optimizer, then it will give us the proper or efficient query execution plan. So role of histogram in optimizer. So whenever the query or request coming to the query optimizer look for the stats, like it will go for the storage engine stats, or it will go for the engine independent stats, which is stored in some of the tables like index stats, table stats, or column stats. So from that stats, it will collect those stats and give to the optimizer will collect those stats and try to frame a execution plan, and accordingly it will give the and depends on the execution plan our query will perform. So if we have the histogram in place, then in the case when the query is coming and which is having a where clause column which is not indexed, and if we have the histogram for that column, then that non-indexed column which is in the where clause will be considered when we have the histogram, and the optimizer will give us the more efficient execution plan, and that can boost our query performance. Yeah, so histogram in MySQL. So this going further, histogram in MySQL will be explained by my colleague Madhavan. Over to you, Madhavan.
Yeah, thanks, Monu. Let me present the screen. So these are the topics we are going to discuss in histogram in MySQL. How histogram is created in MySQL and the use case of the histogram, and how to enable the histogram in MySQL and how to disable it, and what are the types of histogram present in MySQL and its control parameters and limitation of the histograms. So let's see how the histogram is histogram in MySQL. Histogram has been introduced in MySQL at 8.0.3 versions. So it will help the optimizer to perform the query better, and in with respect to column statistics which is having. The column statistic for the histogram can be used for the non-indexed based column. Why? Because if the indexed based column will have higher cardinality and it will faster the queries. If the columns don't have much cardinality, suppose having lesser cardinality, and in that cases indexing will not helpful. So in these cases, if you have distributed of the column with data set as uneven, then histogram will be very much helpful. So and the column which is having not much change, like consider the distinct value of the column is not frequently getting changed, but the records consuming for the particular column is having inserting more, then the amount of range distribution will be huge for the particular column. So in this use case, the histogram will be useful, and the histogram will be stored in the data dictionary of the MySQL, and we can represent the stats via view based in a view. So that view is present in the information schema dot column statistics. Via this views, we can collect the histogram statistics from the data distribution. And histogram use cases. So it will be very much useful for the query which is having where clause which is not indexed. So it will collect the stats and it will optimize the query, and it will give the filtering rate with minimal percentage, and it will be useful for the join based and range based queries. So as I told earlier, so it will be useful for the low cardinality based columns, not for the higher based cardinality, and it will be useful for the uneven distribution of the data. So this cases, the histogram will be very much useful. Let's see how to enable the histogram in MySQL. So histogram can be enabled in two ways, with single column and multi column. So this is the syntax for enabling a single column. Here you can see two differences, one with enabling with a bucket, one with default values. So by enabling with a bucket will represent how much bucket we have to create for the particular column. It's completely based upon the distinct value which is having inside. So by default it will have 100, and max it can able to get 1024. How the histogram can be created with a bucket will be seen in upcoming slides. I will explain you. Yeah, histogram for the multi columns. So if you want to create histogram for the 5 to 6 columns in a single table, means we don't need to specify each command one by one. Instead of that, we can use comma separator, and we can view the columns and we can give the a number of columns for creating the histogram statistics. And error handling. Suppose if the table having 5 columns, we need to create histogram for the 3 columns, and we have mistakenly specified the column 2 as wrong. Then the optimizer, the analyst will not fail to create the histogram for the rest of the columns. It will try to create as much as work possible, and it will create the histogram stats for the column 1 and column 3. So it will do the work as much as possible. So it is a good feature in MySQL error handling when it comes to histogram. And one of the main feature in MySQL is how we have to disable the stats if the histogram is no more required. We can't keep the histogram stats in a disk if that is required. It will so we can drop the histogram with a specific column as well as by specifying comma separator with multiple columns. So we can disable drop the histogram. Yeah. So types of histogram. In MySQL, we have two types of histogram. One is singleton and another one is EQ height. So let's see detail about singleton how it will be and EQ how it will be. So singleton is a create with one value per bucket, and it will store the values with cumulative frequency, and it will useful for the range based and equality based columns. Suppose if the content having 7 distinct values, so in this case by default the bucket is 100, so it is less than the distinct value of the column, right? So then obviously the histogram will go for the singleton instead of EQ height, because it is lesser than the cardinality of the bucket value. And the values will be stored in the histogram stats, right? It will be unique for each bucket. When it comes to EQ height, it will store the multiple value in a bucket, and it will it doesn't sad the values across the bucket. The one value bucket will be unique, and it will not get sad with the other buckets. It will store the min and max for each bucket to show the interval. This is the way the interval of the bucket is there, and it will strictly to the sampling rate 0 to 1, and it will be useful for the range based scan queries. If the distinct value is higher than the bucket value at max, as I told earlier, it will go out in 1024. If the distinct value is more than 1024, then obviously the histogram type will goes to equal height. The parameter which can control the histogram stats in memory. So this is the histogram generation maximum size, which will create the amount of memory available in the server to generate the histogram size. In case of larger tables, by setting it to huge value, will leads to load on the server, and it will lose memory leak, memory consumption, and it will leak out of memory. So in this case, we have to make sure the variable is stick to the system resources based upon the value only. If suppose if the values the needed query ranges which you need to perform the histogram stats is higher value, this value means, then MySQL will sample the data, then it will try to get the histogram with the sampling, not with, it will not take the entire data into memory. It will instead of it will do the sampling, and then it will perform the histogram stats. By default it is 20 MB. We can achieve that in changing in global and session level. And limitation of histogram. So in MySQL, the histogram stats will not frequently repopulated. The stats we have to manually perform to get the updated stats. So in case of hot tables, like the data changes in the table is huge, and we can't create the, we have to we should not use the old stats. We have to populate the stats again in a frequent interval of time using event scheduler based upon the frequency of the timing which we can decide, and it will not useful for the index based column. As I told earlier, index is used for the cardinality more, and which has higher cardinality. In that case, histogram will be not useful. The histogram stats can be collected from the disk only if the optimizer switch condition fan-out filter is turned on. So analysts will be workful for the below engines like InnoDB, MySem, and NDB tables, and it will not work for the views based columns. Suppose if the InnoDB read-only variable is disabled, okay, then the stats which you have created will be useful. Suppose if it is enabled, means the analyst will not update the stats for the upcoming queries. So these are the limitations in histogram in MySQL. So further slides will be taken care by Monu in detail. Over to you, Monu.
Thank you, Madhavan. Let me present my screen. Yeah. So histogram in MariaDB. So we will go through these subtopics like histogramming, what is histogram in MariaDB, use case of histogram in MariaDB, how to enable histogram in MariaDB, and which are the parameters that affect the histogram in MariaDB. And at the end, limitation of histogram, and at the end we will summarize the difference, like what is main difference between MySQL and MariaDB. Yeah. So histogram has been, this feature is enabled from early version of 10.0.2 since 2014. And before the histogram came in the picture in MariaDB, MariaDB uses the storage engine stats. That means for every table, storage engine will store some stats, and that stats will be used by optimizer to defining the execution plan. And after further more improvement, it came to an engine independent statistics. So that engine independent statistics will like there are tables like column stats, index stats, and table stats. So those tables, while running the analyze table, just analyze table name, it will collect those stats and it will store in those tables. And while optimizer, while designing the execution plan, it will go through that stats and give us the proper execution plan, means efficient execution plan that can help our query to improve the performance. Yeah. So and before histograms came in a picture, like all the suppose in a query there is a columns in the where clause which is not indexed. So what do optimizer will do without histogram? It will ignore that column. It will not consider that column while estimating the execution plan. It will not consider. So to consider the non-index column, we should have histogram on those columns. So that in that way we can it will give efficient execution plan, and that can boost the query performance. So histogram, and also in MariaDB we can collect histogram for both, even for column also and even for index also. So both for the both we can collect the histogram stats, and those histogram stats are stored in MySQL.column stats, where the engine independent table statistics are also stored. So we can decode and we can check like which type of histogram is stored, like what is the beans it has. So in MySQL we have a bucket. Bucket is like a range of value or a group of values. So in the same way here we have beans. So that how many beans, when it was last updated, all the details while decoding the histogram with this table we can get it. Yeah, use case. Yeah, similar way, like as I told, like it is the most use cases like when in a query we have a where clause and that are not indexed. So in that time it will be used. And suppose like how we can choose like from which column we can create the histogram. So that depends, like when we have a column with enum data type or with a like gender data type, that we know like they are going to have very minimal distinct value. So for those type of column we can create a histogram, and that will be useful when those columns are passed through when those columns are in where clause, and we our optimizer is framing the execution plan. So that time it will be helpful. Yeah. So this is a one use case. And also like histogram will provide the proper statistics about all columns or the index. So that will be useful for optimizer. So those things will be considered while framing the execution plan. So it is most helpful in when we are when we have to optimize the query, when we don't have the proper index or we can't create an index for the column, and that is costly for that time. So that time this can help us. Yeah. So how to enable the histogram? So enabling the histogram, like we can just analyze table and persistence for all. So this will what it will do, it will enable histogram for all the columns and the index present in the table. And suppose in the case if you are running just analyze table, so that will analyze table name, that will update the states, but that will not update the histogram state. That will update only the table statistics, like how many index, how many new row came to the column, that will update. So for giving the proper histogram we have to use like analyze table and persistence for all. And suppose if you want to create for only for columns or only for indexes, then that time you have to use this syntax like analyze table persistence for columns. You can do you can create for multiple columns at a time and multiple index. Or if you want to create only for columns, then you can mention here columns, and index you can just give an empty set. So vice versa you can do. Yeah. So histogram types. So like MySQL, we have two types, singleton and equi-height. Here we have three types: single precision height balance, double precision height balance, and JSON height balance. So we will go through one by one. Yeah, single precision height balance. It's a like what we can say, like it will be like similar like singleton. So it will have the less precision compared to the double precision heights, and it is by default till 10.4.2. In this, the all the histogram, the buckets or the beans has been divided in the has been given in the fraction, number of fraction, and all those fraction lies between 0.0 to 1. And all these fractions are stored in a single byte, while in double precision it will store in double byte. And then it's give us to the round of number, like suppose if we have histogram size is 20. I will come for the slide, I will explain like what is histogram size. So for as of now, histogram size, like it will define the number of buckets that will be created by the histogram. Like if we have 20, then 20 bucket or bins will be created by the single precision height balance histogram. So if we have 20, then it will be round off to like 20 by 256, because like a histogram size is lies between 0 to 255. So divide by 256, it's overall giving 0.078. So till after decimal three values, three digit precision given by the single precision height balance. In the double precision, it will go for a 5 after decimal 5 of 5 digit. And here the fractions are stored in 2 bytes, and then it's getting round off, and this is by default after 10.4.3. So JSON, like JSON height balance, like here histogram is stored in JSON format and it's introduced in 10.7, but actually it is implemented in 10.2. From 10.2 MariaDB 10.8, we can use the JSON histogram. So what actually JSON histogram? JSON histograms, like in single precision, double precision, all the histogram details, like from which column to which column it has created the bucket and what is the range, everything will be stored in the fraction or in the hexadecimal. That is not readable. But in JSON, we can read it, like from this column to this column, it has created the one bucket, and this bucket has this many distinct value. That will also given from starting ending, everything will be given. So it is more understandable. So it is more human readable, and it will gives more precise data about the column distribution. So this will be help more to the optimizer to choose a proper execution plan, especially for the non-index column in the where clause, and it will help in when we have a joins in queries and when we have a order by queries. So that time it will help, or the columns which is don't change much over the time, like it's having the same type of distinct values coming again and again. So in that case, while we creating the histogram, this will be very helpful. Yeah, so histogram type. So here just I'll conclude, like till 10.4.2, a single precision histogram is was by default, and after 10.4.3, double precision become by default, and after 10.8 we can use double precision, but we can use, sorry, we can use JSON, but double precision is by default. Yeah, so these are the parameters which affect the histogram in MariaDB. So first is user stats tables. We will go through one by one in detail in the further slide. Yeah, so user state table. So this variable user state tables, it's like it's about the table statistics, how optimizer use the table statistics, or how it controls that engine independent table statistics that I earlier told, like the statistics will be stored in MySQL column stats, table stats, or index stat table. So how optimizer will use it, that is controlled by this parameter. So it has 5 more. Never means it will never gonna use any statistics for framing the execution plan. But complementary means it will use that data statistics from those tables, but those table if the data is not available from the storage engine statistics. In preferably, it will first prefer the data statistics from this table, like from this in engine independent table statistics, and if the same kind of data is not provided from the storage engine, then it will prefer the first this engine independent table statistics. Complementary for queries and preferably for queries are same as complementary and preferably, but just it will use for the queries, for the 4 queries. And before 10.4, it was set as never, means it will don't use any histogram or don't use any table statistics. Optimizer will not use anything to frame the execution plan. And after 10.4 and later, it was set to the preferable for queries and by default, and which will use the table statistics while framing the execution plan. Yeah, analyze sample percentage. So this variable introduced in 10.4.3, what this variable do, it will, when we run any analyze table, the number of rows or data will sample so that it can collect the table statistics or it can frame the statistics. So percentage of rows from a table when we run analyze table will sample depend on the value of this parameter. So by default it is 100 means it will go for a full table scan. It will go for a full table scan, means it will try to accumulate all the percentage of data what is present in the table. But that is not good, because if you have a like large table, then accumulating all the things in table statistics will may cause some slow down the performance for that table. So we should set it at 0. So in that case, MariaDB will decide automatically like what percent of row it has to sample to frame the statistics, table statistics. Yeah, histogram size, like as we discussed earlier, like histogram size will it will lies between from 0 to 255, and whatever histogram size we mentioned, that same number of bucket or bins will be created while creating the histogram. And this is effectively for the beans for the histogram type, like single precision, or like whatever number of histogram size we have, same number of bucket or beans will created in single precision, but it will created by beans by 2, means if we have 100, then it will create 50 buckets for double precision. double precision histogram type. And this variable we can set it as globally, like we can set like depends on our cardinality value or depends on the distinct value in a column we have. So accordingly we can set it, and we can change the type of histogram type. Yeah, if it is set to 0, which is default till 10.4.2 and below, no histogram will be created by running analyze table, or neither it will collect a table status. So histogram type. So in MySQL, like MySQL will automatically decide based on the distinct column which type of histogram it will create. But in MariaDB, we can specifically told to system like, yeah, you have to create double precision or single precision or JSON. We can specify using set global histogram type is equal to the type of the name of the histogram, and it we can specify. And till 10.4.3, like double precision is default, and till from 10.8 we can use JSON format histogram, which will be more useful and more understandable, means more readable format. Yeah, optimizer use condition selectivity. So this variable controls like which type of statistics optimizer will look when preparing the execution plan. So this values ranges from 1 to 5 until 10.4.1. 1 is default, and after 10.4, 4 is default. So it gives the selectivity of predicate range predicates. Like for if it has 1, then selectivity of range predicate. If it's 2, then selectivity of index predicates of all range index. Then if it is 3, then it will not use histogram. If it has 4, then it will use histogram. So it will gives the optimizer like which type of stats it can use to give us the best query execution plan. Yeah. Limitation. So likewise in MySQL, as Madhavan said, like we can drop the histogram, but here in MariaDB, there is no specific command to delete or drop the histogram. We can disable its uses of histogram by setting use stats table equal to never in session or global. That depends on our use case. And histogram statistics cannot be collected when we have a column, data type, blob, or text. And also, like if we are running analyze table on a large table, can slow down the database performance. So we have to consider this. Like if we have like a 100 or like 50 or 100 GB of table, then we should consider while creating the analyze table, while creating the histogram. Yeah. So this is a difference between MySQL and MariaDB. As we told earlier, like in MySQL, it is introduced 8.0.3. It introduced here in early version 10.0.2. Here, histogram can MySQL histogram can create for only for columns, but in MariaDB we can create for columns as well as indexes also. And in MySQL we can't drop the histogram, as I said in the previous slide. But here we in MySQL we can drop, but in MariaDB we can't drop. And MySQL supports mostly all the columns. We can create a histogram, all the columns data type, but in MariaDB we can't for blob one text. And also in MySQL we have very limited parameters, like only one, that memory controlling parameter, how much memory will pass or how much memory we can give, like while sampling the data. That only we can control. Here we have many parameters, like we can decide which type of histogram we have to create, which type of what will be the size that we can decide, and what will be the percentage of rows we can pass for collecting the stats. Those things we can decide. So here we have more control. Yeah, so now it's demo time. So Madhavan will explain. Madhavan will go through the demo. Yeah, Madhavan, over to you.
Thanks, Monu. So let's see a quick demo on MySQL and MariaDB. For MySQL, I have installed the latest version community, and for MariaDB, we have used 8.8. So let's see first MySQL. So here I have used the employee schemas for the query analysis. So we have prepared a join for the two tables, uh, for the salaries and the employee tables. So as you see, the salary table is using the filtering percentage of 10 percentage. After creating the histogram, we are going with the default bucket because salary is having the unique value of huge. The salary for each column, distinct value having huge for the per users. It will differ. So the cardinality of the salary is huge. So after creating the histogram, the filter percent has reduced from 10 to 0.5%. So the range of scans will get reduced in the after getting the histogram. So let's see how the histogram type will be calculated based upon the cardinality. So in this part, I have used the world schemas, world databases, and in the world databases, I have used a country column. Country.
Sorry to interrupt, Madhavan. Your screen is not visible. It's not visible properly.
Now it's visible.
Sorry, Madhavan, your screen is not visible.
Is it visible now?
No, Madhavan. Just showing the heading of the terminal. So, can you restart?
Is it visible now?
Yeah.
Visible.
Okay. Sorry for the convenience.
Thank you.
So as I mentioned earlier, I have used employee schemas for the MySQL 8.0 version. In that employee schema, I'm making two tables for the joins for the salary and employee tables, and I have shared the explain plan for those join queries. So the filtering rate is 10%. So after histogram, 10% before histogram, after getting the histogram stats, so the filtering percent has been reduced to 0.5. So as I mentioned earlier, the histogram will be very much helpful for the join based queries. So currently for information, salary is not indexed. So to show the histogram type, how it is creating. So here we have chosen the column which is having low cardinality. So that's why we have chosen the continent column in the world databases. In the world databases in country table. So I have created the histogram for the continent column with the default bucket. So to show the distinct value of the continent, I have using this query. So as you see, only we have 7 continent. So obviously the distinct value is lesser than the current bucket value, which is default. So let me show you the how the histogram stats can be collected from the information schema column statistic views. So it will clearly show which schema which it has created, which table and which column name. And we have used JSON pretty for how the column has been distributed. So in this pretty, we can easily show the how histogram has been created for each buckets. As I mentioned earlier, it will be strictly stick to the sampling rate from 0 to 1. So as it is the distinct value is lesser than the bucket value, so it is went for the singleton. And we can also see when the lastly histogram stat has been updated via this column. So last updated shows when the histogram stat has been updated lastly. But as I mentioned, I have created the default bucket, so that's why the number of buckets specified is 100. To differentiate the type, now I am dropping the histogram on the continent, and I am creating histogram with 5 buckets because the coordinate is having 7. So I'm reducing the bucket. So obviously it will go for the EQ10. Sorry, EQ height. See, the number of bucket has been specified is 5, and the bucket has been created also 5. And it will went for the histogram type as EQ height. So this is how the histogram will create in MySQL. It will decide according to the distinct value and bucket value we are specifying. The bucket by default will be 100. Yeah. So let's move to MariaDB. So here I have used MariaDB 10.8 version. So first, let's see the query performance in MariaDB. So we are using the default histogram type as double precision height balance. So I'm setting to it is a global value. So to show the histogram, what is the size and histogram type. Yes, shown here. By default, the histogram size will be 254. So in our cases, I am increasing to 200. As Monu, my colleague Monu mentioned, we can't drop the histogram. So that's why I am disabling the histogram user stats table to never, to show the query performance before histogram with by using histogram. So here I am using same employee databases. So to get the updated stats, we have to reconnect the system. So as you can see, the filtering percent is 100 before without using the histogram stats. So now I am changing to preferable to queries for the user stat tables to optimize it to pick the histogram stats. So this is the syntax for creating a single histogram for a single column. Here I'm not going to use the index, so I'm not using the specifying the index here. This is only for the column we are going to use. Yeah. So after using the histogram stats, the filter percent has been reduced from 100 to 54 for the employee table, and for salary table it has been used to 0. So this is a filtering. It has been reduced after histogram statistics for the joint base queries. Now let's see how the histogram type, which is storing in the MySQL or MariaDB. So in this case, as I mentioned, salary having huge number of unique values. So I'm setting the histogram size to 100, and I'm going to show the difference how the pins will get in MariaDB. So first I'm converting the histogram type to singleton. In this case, I am using the world schemas for the country column. So here I have used country column, and for continent um, country table and continent column I have used here. So to reconnect, we have to. Yeah. So as I mentioned, it has created the singleton because we have specified the histogram type as singleton, and you can see the histogram size is 100, and it has created the 100 bins, and you can notice the bins which is having 00 values also, because the bin don't have any values, because the cardinality of the column which is having only 7. So only for 7 column we could observe the values. When it comes to double precision, the bucket will be reduced to half of the single precision. Again, updating the stats for the double precision. So here you can see the bin value has been reduced to 50, but the accuracy of the filtering rate has been increased. So this is how the singleton double precision has been differs in case of accuracy and bin storage, as it is storing in 2 bytes. In single precision it is storing in a single byte. When it comes to JSON, in both cases, singleton and double precision, it doesn't have human readable format. When it comes to JSON, we will have more human readable format, which has been implemented in MariaDB 10.8. No histogram has been corrected. Let's see that how JSON has been stored. Here it will store what is the start value of the bucket bin and what is the end value. In case of a numerical way, it will come with the numbers like for the numerical data type like integer for integer based data types. So you can show the NDV. NDV denotes how many unique value present in the bucket. So currently we are having 7 unique values. So each is storing in equal bins. So the NDV is getting 1 only for all the buckets. If we reduce the histogram size value, then the NDV value will get differ with respect to how many unique values stored in that bins. Let me reduce the histogram size to 3 to show the difference. So as we mentioned, the NDV values differed from 1 to 2 with respect to the values is present inside that. This is a few demo for MariaDB and MySQL. Let me so these are the reference blocks which we have added for our slides for the more information. Thank you.
Thank you so much, Madhavan and Monu for such an informative session. I hope all our participants have liked and learnt out of this session.